I hope we can see that there are similarities in the process that is actually carried out when we do big data analytics to utilize the huge data sets with the analytics in common. In general, data analytics cycles can be described like this one. Yeah. Start from discovery of the problem and defining kinds of knowledge that we want to get. Then analyzing to choose which data to be processed. Analyzing the model as we want to obtain. Also, we have to determine the algorithm used to build the model. And then we will interpret the model so that the information can be used to the action. This can be can be done at the stage of operational and communicate the result. Then it is very possible to repeat the cycles because with the new information or knowledge, there also will be a new problem or opportunities. And we want to have to define new knowledge. But when we are dealing with big data, then at building model these steps, it is very necessary to make various adjustments. Based on my experience, the most frequently occurring is the adjustment of the method, or even we have to define a new algorithm. So to taste how this is done, I will try to give an example in the implementation of big data analytics in help data, which is the data is represented as graph. So we need to implement graph mining on big graph. Here is an example of help data presented in the form of heterogeneous graph. Heterogeneous means we have some varieties of nodes where the various kinds of nodes such as P, P, patient profile, and key related to the information of. So the nodes record the information about mental health, current condition, family histories, and so on. And then E nodes means examination results such as weight, height, oral hygiene, femur, neck, and so on. And then the last one is the lab result such as blood pressure, cholesterol, blood selenium, urinary, and so on. And the age represent the person correlation coefficient. So when we know person correlation coefficient between one node and another node shows the higher the coefficient value means that there is a strong relation between two vertices. By doing graph mining, we can find groups of people who, for example, maybe this is the group of heart disease, and then the second group is have a risk of heart disease about 70% at 40 years old, and then the last group is have a kidney problem at 20 years old. Of course, I will not explain the details of the algorithm implemented, but I want you to be able to imagine the challenge when this graph becomes very large, because there are so many patient data, lab result, and examination, also the relation of each node. Keep in mind.
I'm sorry, you have 2 more minutes.
Okay. I will try it faster, okay? Keep in mind, if this graph is very large, of course, we assume it can no longer be processed using only a computer. And the tendency of big data technology is more feasible to use scale-out technique. Means we can okay. Here's some approach how to partition the graph. Sometimes we can split it based on the row of adjacency matrix representation of our column base, or we can also use the vertex cut method. But also there is some problem, and after we successfully splitting the data, we must ensure that the result of the aggregation that can and the result processed without parallel processing are equal. Thus, we need to do various engineering to guarantee the result. Maybe we can redefine the algorithm, or maybe even define more efficient partitioning technique, and so on. So from this explanation, I hope you can taste and see that there are some open problem and many things that need to be researched to support healthcare by utilizing big data analytics. So I hope I still have time. This is my research interest now, that I'm interested in big data analysis for Indonesian people's health personally, or personalization health. Okay, this is my sharing. Hopefully it is useful. Thank you.
Thank you, Dr. Imelda. It was very interesting. We know that we all care about our healthcare, and we want to know how we can analyze data that we have about our health to improve it in the future. I think that's the big idea that I get from your presentation. And then let me share my screen. That was our second presentation today. We will move to the next one. This is from Mr. Aswa Abdul Aziz. He is a senior lecturer at the Faculty Informatik and Komputeran, University Sultan Zainal Abidin. He is a PhD candidate in engineering, University of Aberdeen, Scotland, and his research interest is on big data analytics, educational intelligence, and text mining. Today, he will present his idea in social media analytics for big data. Mr. Aswa, are you ready?
Yes, let me share the screen first. Yeah. Can you see my screen?
Yes, that's okay.
Okay, so can I stop now? We can start now?
Yes, please.
Okay, thank you. Okay, Assalamualaikum, and first of all, I would like to thank to the Telkom University Bandung because invited me to give a public talk about this social media analytics for the big data. It's a huge opportunity for me and also for the faculty. Okay. So a little bit introduction of our university. I am from the Faculty of Informatics and Computing University. So this is our campus. This is a branch campus in Besut Tembila. It's in east coast of Peninsular Malaysia. So we are near the beach, and all this building is a building of the Faculty of Informatics and Computing. And we have a student from overseas and also from the Malaysian student. So then a little bit of myself. I have 15 years experience in I consider as a data scientist. I've been in industry for 6 to 7 years. The last position as a business intelligence consultant and developer before I joined as a lecturer in 2010. Now I also senior lecturer and waiting Viva in PhD University Aberdeen in the topic of the sentiment analysis again. So let's talk about the social media first, okay? So why social media is important today? Why is important? And when we talk about the big data analytics, it's always related to the social media, okay? Because everybody now work as a sensor because everyone has their own mobile phone, and one mobile phone, there has many applications of social media. You have Facebook, YouTube, WhatsApp, and everything against social media. I believe some of us, when wake up early in the morning, you just take your phone and you just say that early morning, done prayer and something like that. So you like to share everything in the Facebook. And that's a normal today. Then some of this information is really critical and help other people and knowing something. And it can be, sometimes we say that when you update something, nobody can use this, but even this little information, when combined with all the information, is become something that valuable inside. So that's it's about data, how you turn this raw data into the something meaningful. I mean, that's how the big data came in. I mean, the big data is already there before this, but with the technology itself and with the technique itself and with the platform itself that much lesser, I mean, not expensive today, then we can use more advanced technology to deal with data. So this is the fact about data. What happened in 1 minute? So yeah, you can see that we have 300 application download, 390,000 application download, 1 minute login, in minute, 40-minute video watching and everything. Then you can see the active user, this site. So this must be really a lot of information. So does social media tell you what the big data criteria? So based on True Presenter, we have talked about the volume. Of course, we have volume of enough and too much volume of the data in social media. We have a variety of data. Yes, of course, we have all type of data from the Twitter, from the Facebook, and the nature of data is also different. What I mean is, sometimes in text, sometimes in the emotion, you know that emotion also emoticon. So emoticon also can use as a tool to analyze data for sentiment analysis. For example, we have the velocity that refer the frequency of data. I mean, in 1 minute, how many data is created in the social media is really a lot. And we have a veracity, how we want to define the quality of data. And for DV, what we're trying to do is want to create something value inside that we call a value. So that is how big data is really important in social media. We try to mix of this, try to analyze for this, and came out the value that we can use for further decision making. Okay. This is example of how big data used in social media. Okay, of course we have using in marketing a lot. So that's why in Facebook, without nowhere, without anything, you just think of your head, and sometimes come out. Oh, you just think that you want to buy, like for example, you want to buy a new car, and tomorrow you have a car advertisement in your Facebook without nowhere. I mean, the real, as you see, is no without nowhere, but maybe there's there's algorithm to come up with it. Maybe you have searching the Google, or you have viewed some surfing some net about the price of the car, then that's why this is that's why the advertisement come to your Facebook. And we also use for the personalization. I mean, you put everything inside, and Facebook itself can create an algorithm to create personalize you. I mean, to identify you, to know what's your opinion, to know what you think. And of course, yes, I talk about opinion such as sentiment analysis that we use to gain opinion from the inside. And political campaign, of course, now the politician is used a lot of social media to gain interest. Okay, for example, in this picture, what you can see, that's what people say about the Trump when during the Trump-Hillary campaign in 2016 election. So that you know that when you read many people that how Trump win, one of factor that influence is how active or how the team of social media is at, sharing the information and faster. So that's an important thing. So example on research study on this, well, I say in social media about sentiment. We also discuss about social network analysis, about human consideration, and also about security. I mean, there are a lot of things you can use security for social media. I mean, for example, if you talk about COVID-19, you want to know for the next outbreak. So what you can do is, if someone tweet on Twitter, there's some case there, so you can pick up the algorithm and you can analyze that algorithm on the case, and you try to find another important thing that before you want to, I mean, you want to solve that the information is really believable, then you can make decision of this. I mean, you can do using the social media, because nowadays people can talk or express all the things in the social media. So what's more important is how we want to do the algorithm, how we want to choose the right algorithm, and how we want to make sure that the information is believable. I mean, that's an important key here. Okay, I take one challenge. What difference social media atau data in social media with other data? Of course, the data social media is a text. Okay, that's one of the challenge. I mean, the text is unstructured data. Okay, when unstructured data, okay, then one more thing, the social media is people tend to write is something that's not use a proper language. I mean, they use all the abbreviation, use of the slang, and in Malaysia itself, I can take example of Malaysia. We have our official language, the Malay language, but people keen to write on what we call that mixed language. We have the Malay English language, we have a Malay Chinese language, we have Malay. Everything is so mixed that people in real life talk about that. So the issue is how you want to understand that, because there's no defined rule for this. So I will talk about later about this one. That's why I take some of challenge if you want to do the social media analysis. Though this is someone of challenge, even though it's a sentiment analysis, but it's all about the text in the social media. We talk about the polysemy because there's limited time, so I share a little bit about this. I'm not go into detail of this. One that I can share is about the challenge in the machine learning. Supervised machine learning is we don't have enough training data. What is training data? I mean, in order you want to predict something, you have label data that say this is something, this is good, is bad, something like that. So if you have training data, then you can make a prediction. Same the example of by Dr. Hardiman that gave about the dog and cat before. Okay. Then if you go for the linguistic resources, so of course, there's many, we have a challenge to understand the human language. Even in the research, I mean, this challenge and also opportunity, even in, I believe for Indonesia too, we don't have enough research to understand the language or to understand, to get information using the Indonesian language or Malaysian language. We have many researchers that focus on English, on Chinese, now in Arabic. I mean, this is a time for us to cooperate and solve this thing. So okay, I talk about the polysemy. Okay, this is more term in NLP term that, okay, let's say about the apple. If you go to the market and you ask for the apple, of course, what you get is apple, right? The apple you can eat, not the apple that costs more than in 3,000 or 2,000, right? Because you go to the market. But if you go to the shopping center, that's a different thing. But for the machine, for the machine to understand what you ask, like apple, which apple you want to do, or to distinguish between apple to eat and apple that you use for computer, is a totally difficult term. That's why we, this is also a challenge. And in if reflect to the language, so we have like, can take example for Indonesian Malaysian language, we have some term that gives different information in this local context. You say that some term in Indonesia, a good term, maybe a good term in Malaysia, but when you talk about in Indonesia, it's not a good term. I mean, how you want to solve this thing? So that's one a challenge, and also I say the opportunity to solve the problem. Okay. So I talk about technique also. So this is example one of, we want to understand the social media data. And I take an example from sentiment analysis. Of course, we have machine learning, what we told today. We have supervised and supervised. We have another approach that we call the lexicon based. So in lexicon based, it's more to understand the language semantic. So this one, the people in the NLP, natural language processing, or NLG, try to solve. So they are looking more on structure of language. I can share a few problems. I mean, a few challenges. If you talk about the machine learning for supervised, of course, we need to have many label data. I mean, if you there are new word, or if there are no style of speaking, or do you know event, so you need to come up with the new label. That of course that's totally expensive in terms of hire people and in terms of validation and so on. I think this is main challenge on supervised on machine learning. That most of the text learning to understand big data is using this kind of the technique. For the landscape based is focused on the grammatical on language itself. But however, what I say the main problem in Twitter, in Facebook, people don't say what in the dictionary or in the book say. So you need to understand to learn and more understand technique. This, I mean, there's cross technique that is called hybrid, and also that a technique that we call that more to statistical based approach to understand this. So in this talk, I just give overview of this, how some technique can solve the problem. Okay. This example how you're using the supervised technique to understand the text from Facebook and so on. So this is normal process that we do before we gain the result. You have the text processing, try to understand, try to get what the text that require. You have feature extraction. I mean, the feature extraction in the text is really challenging compared to the structured data, because you have too many features. You need to have a right method to select the feature. So there are most popular method like count iteration, TF-IDF, and many techniques that use for the features. Then feature extraction itself, there are one study on that. There are one focus study on that. So there's a huge research going there. So we have vector representation, and after that we have sentiment classification, just to identify whether the text is positive or negative, or this one, and we try to summarize all the result. This is more like supervised training. Okay. Then how you want to understand something? There are several training on this. One of the popular training NLP, I mean, it's not really NLP, it's more like to breaking down word into the back of token. I mean, to calculate how many nation, like this in nation 5, how many nation is speak on this. So you try to take the feature, you try to create a feature from the text. So this is one area of research study is really interesting now. So then, and there's still lack of research going to understand this, how our continent, like the Malay language, Malaysian language, and I believe also Indonesian language in there. So this is huge research in there. So how we want to do this, okay? So this is, if you are using an NLP approach, so we have a lot of how to define, how to differentiate between noun, the complex, that this is why they use some of, we call that linguistic resources or lexical database, like the WordNet on to understand the term. For my current knowledge is, I don't know if there's still available research. I have it, I believe it's there for the lexical base for Indonesian language or Malaysian language that really focus on to do the NLP process in that. I believe there's
Mr.
something.
Aswan, I'm sorry, you have 2 more minutes for the question.
Yeah, thank you. Okay. So, I try to conclude back what I say before that. I talk about I talk about the social media data. You see, I'll talk about the social media data and the big data, how the social media influence our life. I mean, that's is really important now. Kind of important thing to say, because we using social media data to understand people. Okay, why social media data is using to understand people? Because if some people, I think most of people, when we talk about the in front, face to face, sometimes you cannot know what's inside or what you say. But people tend to express all the things in social media. Maybe you can see that when people in a social media, it's a different kind of when you meet with people. So this is important information that we can use. I say that in all the way of domain, from the political, from marketing, from security, and the list goes on. Okay. Then I talk about the challenge for sentiment, for text, to understand the text in social media data. And of course, before I forget, this is based on mostly one of another challenge in social media data is sarcasm. So sarcasm is really difficult to understand because you say something good, but you mean something bad. So you want to computer to understand that. So it's totally different level. So how you classify on this. So that's why some of research study that going on sarcasm is focused on the emoticon that display on the sarcasm. So that's another interesting research. So I talk about training in the some of training that used in social media. We have machine learning, lexical-based hybrid, and some studies about the statistical. And I also talk about opportunity. So I mean, in our continent, we say that in our Nusantara, from Borneo, from Kalimantan, to Indonesia, Bandung, Jakarta. So I left to go to Bandung before. My last time go Bandung is really good experience, and I left to go there again. It's really cool there. So it's a summer, like a summer in Aberdeen. So what main opportunity here is we can sit together and see our, because we talk, our language is different between our continent with other continent, and how people express something in the social media knowledge is also I mean it's localized. I mean it's local unique. Okay, before I go, says one example. That's one I think that one word that have a different meaning. There's also a case that many words they have one meaning. If you say that the word we call that in Malaysia we call eat or makan. Makan in Terengganu, there are two states in Malaysia. That's my state and another state. Just another state. One say that it's makang, it's more the ag, M-A-K-N-G, and another say it's make, M-A-K-E. So how you want to differentiate this thing, similar thing, also become one of interesting to look at. I mean, most people look in Chinese, most people look in English, and now it's in Arabic, but I mean, not many races in our area. I think that's a huge amount that we can move forward. I mean, I think that's all for me. So I will give to the Tajulna again, and thank you for giving me opportunity for this one.
All right, thank you, Mr. Aswa. We don't really usually think much when we posting or we share something in social media, but we learn now that we can really study or learn a lot, analyze the data from social media. Thank you. That is very interesting. Now I would like all of us to switch our attention to our fourth speaker. Let me share my screen first. Our fourth speaker is Dr. Kemas Masalah. He is a senior lecturer at the School of Computing Telkom University, and he is a PhD in Computing Science, University of Aberdeen, just finished in 2020. And his research interests are in data science and semantic big data. Today he will present his thought in semantic big data. Mr. Kemas, you may now present your.
Yeah. Thank you, Dr. Angelina. So share. Can you see my desktop now?
Yes.
Yes. Hello, everyone. Welcome to the webinar today. So I'm very grateful, I'm very cheerful that many students, many practitioners came from Malaysia and also from Indonesia, many of our colleges. So today I will talk about semantic big data, and I will start my presentation with one question. Assume that we have 200 terabytes data from telecommunication sector. My question is this data big? If I ask this question in classroom, I will get different answers. Maybe one student will say, yes, Cam, that data is definitely big. Maybe the other student say, no, It's not big, it's tiny. So all of these different answers happen because there is missing information here. There is one information that need to include it into the picture, to the slide. So if we put the information into the slide, for example, we have 200 terabytes data, and also we have another information. We have a supercomputer with 4,800 terabytes memory. Now, my question still the same. Is this data big? I think all the students will answer definitely no. This data is very, very tiny. Yeah, because the memory, with this size of memory, we can swallow, we can put the data inside our mouth, and then we digest it just in one go. And then you might ask me, what is the biggest data available today? So in 2019, there was a project called Square Kilometer Array, or SKA. So this project was aiming to see the sky, to take the photo of the universe regularly, and then to record it and send it to the Earth stations, and then to analyze it. Their estimation, this is just estimation, and usually the real implementation will produce more data than the estimation. So they estimate that every year, the volume of the data stored by the SKA data storage would fill over 1,500,000 gigabyte laptops, huge number. And also every day, they estimate that SKA will send 1 petabyte of image cubes per day to Earth. If we compare these figures with the supercomputing power that we have in 2019, on average, there was no supercomputer that can process this 1 petabyte. And we need to remember this 1 petabyte is not the real data. This is just the incremental data that added for every day. The actual data is much, much more bigger than this. All this discussion bring us to the definition of big data. In my opinion, yeah, it is not about the size. So big data is not about the size. It is about how you can process the data that goes beyond the computing power that you have. Yeah, there are two possibilities here. First, either the data continuously flows like a river. So the data flows, always flows from the user to our data storage, or maybe from our data storage to the users. And then the second option is we collect the data in batch mode. So after 1 week, or maybe after 2 days, we collect the data. So there are two possibilities, data streams, they call it. The first option is data stream, and then the second is batch processing. So for either possibilities, we have a limitation, how we can process data with this limitation. So that is big data, in my opinion. And then let's talk about semantic. Yeah, semantic, according to a very famous paper, it was written by Tim Berners-Lee as the head author and his colleagues in 2001. So in his very, very phenomenal paper, Tim Berners-Lee said that semantic is the philosophy of meaning. So not the structure of the data, but the meaning. If we combine together semantic and big data, we have three possibilities of definition. The first definition, I borrow it from Wood's 1975. So it's quite old because big data is that new term, yeah? The definition of semantic big data is meaning and meaningful use of big data. And then we move to the recent definition of semantic big data from Cherafolo, 2018. He said that semantic big data is using semantic technology to support big data management. And then, according to me, myself, so semantic big data is how to process the data that goes beyond your computing power in a semantic manner or semantically. Now let's go to the details. There are three approaches for implementing semantic text technologies to big data. First is semantics from the models, and then the second, semantics from the data itself, and the third, semantics from users. This was based on Jordan 2019. Yeah, he authored a paper, Big Data and Database Semantics, and he proposed this. Semantics from models, the first one. In semantic web, we have two de facto standards, very, very famous standard. First is resources data format, RDF. So we use RDF models to model the data as triples. Now, triples mean a sentence, very, very atomic sentence, consists of entities, Bandung, West Java, and then relate by a predicate. In this example, city in. So we have two entities, Bandung, West Java, and then city in. So these are the RDF triples, yeah, or triples that was comply to the RDF standard. And then web ontology language, or OWL. So we use OWL for defining the schema of the data. Yeah, if you know relational database, you know that we have ER diagram. ER diagram for unstructured or maybe for semi-structured data. Yeah, we can use OWL for using that, because OWL define the concepts that we need to play with in our data, and then it will also define all the relationship among the concepts and also the hierarchy of the concepts. And we can reuse it. We can reuse it. Yeah. And then the second semantics is semantics from data. Yeah, semantics from data, meaning the data itself already rich, already has meaningful. Data is already meaningful. So we just need to add statistical approaches. We just need to apply linguistic approaches to get the information that is already in semantic manner. And then the third one is semantics from users. This is quite new. In semantics from user, we ask the user to annotate, to tag the data, to add description about the data. By using this, we believe that if the users are responsibility people, then the taggings that they did, it will be available resources for us. It will give the correct interpretation of the piece of data. Now let's see what are the examples of semantic big data. First, I would like to advertise my work first. During my thesis, I developed a consistency checker. So if you give a piece of a fact to my software, I can come up with an answer whether this fact is consistent according to schema or not. In my thesis, actually, I'm just playing with 200 megabytes size of data. If we compare with the memory that I use, it's quite, I think you can say it's very, very small, 200 megabytes compared with 15 gigabytes. But yeah, Dr. Hadiman knows my research very well. So in my research, there is data part and there is schema part. Schema is so small, data is quite bigger. But if we cross it together, then it will produce big operations. In my case, I need to cross it over and over again. So the result of this crossing operation can generate 20 gigabyte data. So the data itself is not big compared with the resources, but the operation between the data itself demanding me to come up with approximate way to make it doable in 5 hours. Yeah, the existing work, they can do it in 15 days, but my approach can handle the cross operation between the schema and 200 megabytes in just less than 5 hours. But yet, what I did is not big data, because when I finish my thesis, I know that there is one knowledge graph that has 1.2 terabyte data. Yeah, this is Microsoft Academic Knowledge Graph. So Microsoft Academic has 1.2 terabytes, so big. And if I cross with the schema of Microsoft itself, it will produce a problem for me. And how if I want to process it with the same resources? My idea is to use semantic processing. I have two options. First, using modular consistency checking. So in modular, this is the big cake, yeah, the big A box. I cut it into pieces. I took one piece and then I cross it. I operate it with the schema. After I check all the triples in the piece, and then I put it aside, I took another piece of the big cake. So I do it modular. But if it is still too slow, then I was thinking about using abstract reasoning. So in abstract reasoning, this is big A box. I will not cut it into pieces, but I will compress it. So I will compress it like zip, yeah, like RAR, and then I will play with this compressed data or knowledge graph. Yeah, if I compress it correctly, then if I run the reasoning on this compressed file, it will be sound and complete. It will be sufficient. But this is just hypothesis. I'm not playing this yet, but I'm advertising to you if you have any project, if you have any energy to do it, just contact me. And then the second example, I think you guys know about Cambridge semantics, right? This is very popular. This was very popular when Trump, yeah, the case of the Trump, yeah. So people know about Cambridge semantic. In Cambridge semantic, the key part of Cambridge semantic is ANZO knowledge graph management system. This ANZO knowledge graph has the power to do online analytical processing. So this ANZO can do data warehouse tasks. Yeah, there are two options that ANZO can do. First is process all the enterprise data sources in one go. So ANZO is big in memory knowledge graph. They process it in memory, and then they can digest it. They can model it. They can give report. They can analyze it. Yeah, because ANZO is like knowledge graph management system or knowledge graph data system plus online analytical or data warehouse tool. So it has two abilities. I cannot go detail on Cambridge semantic because this platform is not open source. And then the third one is Big Owl. So Big Owl, proposed by Barba Gonzalez, yeah, in 2019. The key idea is to use the ontology to drive the big data platform. Yeah. And they use semantic technologies to annotate the big data sources. There are two models that they use in their system. First, operational model. So in operational model, they put all the data, structured, semi-structured, unstructured, just put it, dump it here in data lake. And then if a request came, if people want to do analysis, they can define it. The engineer can define it in this workflow composition. And then in semantic model, this model act as intermediate or mediator between whom? Between the users and the operational model. So the semantic model will help operational model in answering the user's query by providing semantic meaning. And the way they make the data become meaningful by annotate what things that they annotate metadata. You know, metadata is like the log of the data. Metadata is the something or everything that they use for describe data. So they have annotation module that annotate the metadata, and then it will help a task here in workflow composition to find the correct data for the type of metadata. Yeah. And also there are T box and A box. T box is terminological box. Yeah. A box is assertions box. T box is schema. I will give you example after this. What is T box look like and what is A box look like. A box is like instances. Yeah. Instances mean if you have a group called company. Yeah. Company. And then the instance of this concept is Malaysia Telkom, Telkom Indonesia, Indosat, XL, okay? Malaysia Airlines. So these instances, we call it instance of a box, yeah? And every instance has their own data in the data lake. But the concept that subsume all these instances is in T-box. They are in T-box, right? So like company, professions, athlete, these are the concepts. This is T-box. Not only helping user to the right data by using metadata, Big Owl also help the users to enrich the data lake. It's quite interesting because you know that data lake is already big. You want to enrich it. It's like you have a lake full of water and then you add more water to it. Big Owl can do it. How? So they have the terminological here. They have the schema here. If they run the schema and the instances, if they do reasoning based on these two components, they can produce new fact and they can push the new fact into the data lake. Here is the illustration. Yeah, how reasoning in Big Owl can add new fact. So this is the schema. Yes.
You have 2 more minutes.
Okay, and then this is the existing facts. Mr. Bean is a comedian, first existing fact, and comedian is an artist, second fact. Based on these two facts, and also this hierarchy, we can see that comedian is subclass of artist, right? So the reasoner can produce new triple or new fact. Mr. Bean is an artist. And then we can put this new triple into the data lake. Potential topics for research. I hope that these are the takeaways for you after you finish hearing our presentation today. First, I propose Microsoft Academic Knowledge Graph. Yeah. Big knowledge graph. You can do many things here. For example, measuring. You can measure the popularity of papers. You even can analyze the evolution of topics. For example, how is the evolution of artificial intelligence from 1970 until now? You can do it by put something on top Microsoft Academic. And then the second, Facebook Knowledge Graph Completion Tool. Knowledge Graph Completion is a tool that can add more knowledge into your knowledge graph. And before Facebook launched this tool, there were no people that play with big graph. Yeah, all people play with small graphs, just like thousands of triple. But Facebook make it open source. Yeah, this is open source. You can click this, and in this link you can see many possible tasks that you can make it into your topic. Maybe, for example, for your undergraduate project, or maybe for your master project. And then the third one is modular consistency checking for big knowledge graph. I already have the code, but not modular yet, and not for big one yet. Yeah, just for the small one, but we can customize it. And the last one is very, very exciting, data streams query processing. I only know a little bit, but this is very, very challenging, and it will be useful for your next career. This slide conclude my presentation today. I hope that you guys can get insight and many good things from my presentation, and then you will have idea for your next research. Thank you very much for listening to my presentation, and terima kasih.
Thank you, Dr. Akrimas, for your presentation. That was very interesting, especially to finish our sequence of 4 presentations directly. Now we will go to our next session, which is question and answer session. I would like to ask all 4 presenters to turn on your camera, please. Mr. Aswa, Dr. Kemas, Dr. Imelda, and Dr. Hardiman, so we can try to answer the questions smoothly. For the first round, I will read the questions that we have in the group chat. I see that some question has been answered by some speakers, but we will try to elaborate again to see if we can add more response to the question. The first one, let me try to go to the first one. The first one is from Ms. Asnia. She asked Dr. Muhammad Hardiman Barawi, could you please let us know how does big data analytics always related to machine learning? What is something new from big data analytics which is different from traditional machine learning before? Thank you. Dr. Hardiman, could you please respond on that?
No. Yeah. So again, no big data analytics. Yeah. So nowadays, because we have our machine have been concluded to become more powerful nowadays. So that's why this big data, big data is large part of data. That's why it's always related with machine learning. But is machine learning the only way to analyze the data? No, we have other techniques as well. We have the statistic technique, we have the linguistic. There's so many other techniques that can be used. But of course, when we talk about machine learning, you are using the power of the machine to get the insights about the data. And of course, sometimes, when you talk about machine learning and statistics, you'll get confused. When I was in this field, I get confused most of the time. In machine learning, we talk about linear regression. And then I opened statistic, beginner to statistic. I also found out that there is a subject called linear regression. So people will ask, what is the difference between these two things? Huh? Is it two different things? Linear regression, machine learning, linear regression, statistics, is it two different things? No, it's the same thing. But what makes machine learning different from statistics? Okay, the thing is about this. This is the important point. Yeah. So in machine learning, usually when we want to analyze, when we want to do the training data, we will be splitting our data into 2 parts. We call it training data and test data. One is purely statistical. We just go one go. We don't do like, oh, this part. That's number 1. Number 2, usually in machine learning, we do it for prediction. Okay. In statistical, if you put new data, some approach can, but most of the approach you can't do because you have not seen the data before. So that's one of the we can say major differences between these 2 things. Then so what's it? Which is different? Okay, is there something new from the big data analytics which is different from traditional machine learning? So I don't. Okay, so something new from big data analytics. So okay, I can talk about the analysis thing. Okay, so currently there are few big breakthrough in the analysis or in the machine learning. The latest one will be we have what we call the cognitive computing. So what cognitive computing does by the IBM Watson. Okay, so what it does is it will have all of these machine learning approaches. For example, SVM, naive Bayes, most of these approaches, CNN, RNN, yeah, all of these approaches, they will test it on the data. Then after that, they will perform some evaluation, and then they will say, okay, then average. Okay, they say this is the solution for this. So this is the been introduced by the IBM Watson cognitive computing. You can do this without using the system as well. You can download a Weka. You can do one by one. So what you do, you have a data. You run all these approaches, whatever approach you choose, naive Bayes and whatever, and then you look at the graph, and then you say, okay, I will choose this, and then you do the average. To what? To do your hyperparameter training. So this is the thing. Yeah, I think for us, yeah, I hope this will answer your question.
Okay, thank you, Dr. Hardiman. Maybe the other speakers, you want to add anything? Dr. Kemas, Dr. Imelda, Mr. Aswa, do you want to add anything to this question? No?
So in my slide, I said that we can use semantics from data, and we can see clearly in my slide that semantics from data is not using machine learning for digesting, for processing, for analyze the big data. So machine learning is just like a type of knife. You have big eggplant, big data. How you want to cut it? You want to use knife? Okay, this is machine learning. Maybe somebody will use another statistical. Yes, you can use semantic by using tagging the metadata. You can use it. So if you really what do we call it? If you really like machine learning so much, then you will approach this big data problem with machine learning. But if you don't have any artificial intelligence ability, but you know statistic, still you can play with this big data by using statistic. Yeah.
If I can add about this one is what most important is to understand the problem, and before then you got the right solution. And we have to understand the machine learning itself and big data concept itself. I mean, if we can see the big data is not a new term. I mean, it's a new term, but it's not new thing. The data itself appeared, I mean, more than 30 years ago. But nowadays we see that there are many, the platform, the infra is much not expensive, and everyone create a data, then it come big data. Then he create their own challenge. Then in traditional data mining, if I can touch a little bit, that all the method need to evolve. Like our COVID-19, this is ever evolve, right? Every day, mutate every day. That's why you see some algorithm become evolve in a way that can handle the big data itself. You see that decision tree, how the decision tree, now we're dealing with the data become the random forest classifier. Instead of tree, now we become forest. Hopefully not Amazon later. But now how you can see the difference. And if naive Bayes, now we have multinomial naive Bayes. Same for the deep learning. I mean, deep learning is also not new thing. But if you say that neural network exists more than 30 or 40 years ago, okay? But the machine itself not capable to do what people tend to do. So that's a problem. Then when we have the machine that already can do data and we have enough data to do this, so that's why deep learning always is related to the big data, because the ability of hidden layer to learn by itself. I mean, the most important thing, even you not use a machine learning or you use machine learning, you need to understand the problem itself, you need to understand the algorithm that you use, and you need to understand the output that you want. So because that is how you want to solve the problem. I think that's for me.
Okay, thank you. I think that's very clear that we can use machine learning as one of many tools or many approach that we can choose to solve different problems in big data analytics. Now we will move to the second question. This is for Mr. Aswa. This is from Ammar. Mr. Aswa, one of the challenges in text mining is slang. But do languages like English not use slang in everyday conversation or in writing comments, because English has its own library? Thank you. Could you please comment on that, Mr. Aswa?
Okay, on this part there are some library for the slang, but I say that slang is not in English. They have some slang library, but like I say, that slang is evolved like daily. It's not it's difficult to track the slang. If you're using the linguistic resources, it's limited to that. Even in English, in UK, we have different slang speak in Liverpool, different slang speak in Aberdeen. Even the nearby Aberdeen in Edinburgh, they also have different slang and how they speak in language in the social media. So I mean, I'm not biased to the NLP approach, but in terms of dealing with the rapid movement, I mean rapid involvement of the language in the text in the social media, I believe that there's many ways. Maybe the machine learning is much better way, combined with the NLP. Of course, the NLP stuff to the pre-processing is much better way, rather than depend on the lexicon to do that. So that's my answer.
Thank you. Maybe anything more from Dr. Hardiman, Dr. Kemas, or Dr. Imelda? Is it clear enough? No, okay. That's good. And then we will move to the next question. The third one is for Dr. Imelda. From your presentation, you were able to identify groups of patients with different type of diseases. Does your method can be used to identify the correlation between diseases as well? Dr. Imelda, could you please answer that?
Okay, let me share my slide first.
Okay, you can do it. Oh.
Okay, can you see my slide?
Yes, I can see it.
Okay. The question is whether it can be used to identify the correlation between disease. Actually, the information is attached on the age. Yeah, you can see that I give an explanation here that on the age we can attach information about person correlation coefficient. So it's, for example, you can see here the third person, the third patient, actually is a member of the have kidney problems at 25 years old, and he or she has a relation to the examination result from the other cluster that shows that this is the cluster that related to heart attack. So I think if there is a correlation between this the member of this class and the member of this class, which is show the different disease. So it shows the correlation between different disease. Though because I haven't tried it, I think we have to prove it by do some experiments. That's my answer. Thank you.
Okay. I think maybe Dr. Kemas, Dr. Hadiman, or Mr. Aswal want to add anything to that? No? Okay, if it's not, then we will move to the next question. I think I missed one question before that. This is for Dr. Hadiman. People nowadays always associate big data with deep learning. What is the difference between those two, do you think, Dr. Hadiman?
Yeah, so people associate, big data with
Deep learning.
deep learning. So what's the relation or why? Okay, so to answer this question, you have to know what is deep learning actually. So deep learning is actually a part of machine learning. So you have machine learning, under machine learning you have deep learning, you have all these other methods as well, gradients, many methods. Yeah, so this is one of the approaches in the machine learning. So why deep learning is always associated with data? Because deep learning is actually designed for a lot of data. So you cannot apply deep learning, for example, in social sciences data. For example, you are doing interview where you need to do qualitative research. You need to analyze 300 people interview. You put this inside deep learning, they cannot. It will fail. So deep learning designed for, okay, the more you have, the more stronger you have. So this is why most of these deep learning approaches are associated with big data. Actually, like what Zola mentioned before, deep learning, the old name for deep learning is artificial neural networks. And back in the 90s, early 2000s, people start to market as deep learning. Why? Because they already add more layers into it. And then they deal with the RNN, CNN, and all this stuff. Yeah, so I hope that answered the question.
Okay, any
I'd like to go deeper to ask you a question about the deep learning and big data. So is there any guarantee that if we go deeper in the deep learning, it will help us to get the analytics result faster? than only shallow layers.
So,
Sorry for troubling you.
So is that question for me?
Yes.
Yeah. Oh yeah. Okay. So what happened is most of us, if you are still new in this area of machine learning, deep learning, what happened is we tend to do overfitting. You know, we analyze too much. So when we do this, you know, you put too much layer, you become too good in your training set. What happens is if you put the test set, you will have a very low result. We call it high. What's that term called? High variance. Yeah. Things like that. Yeah.
So overfitting can be happen if we put
Most
more
of the time.
Yeah.
layers.
If I can add, because I mean, that's why I say that the main thing is we see our problem first, and even if you see the deep learning research, much more used in face recognition, in pattern recognition, is because there are many, what we call, there are many features, there are many sparsity on that. So that's why deep learning is useful in that. But if you are using is in normal data, it become overfitting, and it may impact the result itself. So then you need to understand all the criteria in big data. I mean, deep learning also can be supervised and unsupervised. We need to understand which technique in deep learning that we are used, then we can expect what the result is. But still, the main thing is we need to look what we want to achieve and the data that we have to analyze. I mean, that's a very important thing.
Okay. Thank you. I think we will move to the next question, and this is, I think, the last question in the chat box. This is for Dr. Aswa Aziz. I would like to ask if there are any ethical problems when dealing with data from social media, because the users may not know that the things they are sharing are gathered and analyzed. Thank you.
I think this really good question, because I think when I present in public in artificial topic in Aberdeen to the public, then we also have this kind of question. It's all about the ethical. So that's why I mean, starting we have an act that something that to keep privacy. But sometimes we don't, when we install something like Facebook and so on, there when sharing something, we just click without thinking about what it say. That is an important thing, that whether we want to share this to public or not. Okay, and mostly the data that I have in public can use for the research. For example, for Twitter data, that Twitter data automatic to be public, you can use API to download all this Twitter data everywhere in the world, and you can analyze that because you already put in the public. I think same for the Facebook. If you are Facebook, you state the status in the public that everybody can use for for analyze. Okay, but if you specify this before you using the social media, it's a different story. We can see the study by, I mean, the case on 2018 Cambridge Analytica is quite popular case when Facebook using this data, the early data that stayed for the research, but then they use this data for political gain that used for the Trump and Hillary campaign, and it become a scandal, a big scandal, because they use the data that's not come from the individual itself, but also the data collect from the friend in the Facebook, the group of friends, that they don't share this data to the public. I mean, that thing, that's a thing that you can sue or you can have, because the data is already declared the privacy, that means the data is being protected. The issue here is whether when we download something, like we want to share location, the apps, I mean, something like that, most of people here, or even me, sometimes we don't see what is there really properly. So that's the difference when we click something that maybe the data is already used for the public. That's why some marketing, some Facebook that can advertise something that we really think, and because we have sharing this data to the public. Okay, I think maybe Dr. Hadiman or anybody that Kemas can add for the answer.
I would like to ask a question about your research as well. So you mentioned about sentiment analysis, right? Yeah. Sentiment analysis. When I came back from Aberdeen and I dealing with students project, I never see big size of data in their presentation. So that make me feel, is this field, sentiment analysis, really big? So that's why I'm asking to the expert here, how big the data that you play with when you are still in Aberdeen.
I mean, the big data is subjective, but for me, because sometimes if you say that the data is based on the size, but the local thing, I mean, you take some source. So the local or the analyze is the same thing, even 100,000, but they ask, I mean, the feature is not really big as we think, because it's the same source. So when I study in Aberdeen, I'm using data from Amazon. I mean, data from Amazon itself is not very much, around 10,000. 10,000 cost domain. I'm using from the IMDb database around 50,000. And also
50,000 users, 50,000.
50,000, yeah, 50,000. And also you need the fake news speed around 20,000. So because in my focus of research, we look what we call the cross-domain sentiment analysis. So I need to understand if you talk about the movie, you say the positive of movie, but something, the word when you say in the other thing is not really positive and come back. For example, I can give example like the sparsity that I give, that you say about something the movie is really unpredictable. So you can think that, oh, this is really positive comment. But if you go to the car review and say that the steering is unpredictable, I mean, that's a bad thing to do. So how you want to classify this? How you want to identify this? That's why in my approach, we're looking for the context. What the context that this should be. So that's the idea. But in terms of your question, how many enough data to do the research? I mean, it's depend on what we want to use. I mean, the local content is there. If we are focusing like for the Indonesia aspect, maybe for the local region itself or local state itself, maybe it's different thing. Maybe it's not much as we can use now. But I mean, the more important thing is how many features that what we want to use. I mean, that's when we think about features, then we think about what data that we want to use. Okay.
Okay. Size in big data, in big sentiment is about the features. Thank you for the insights, Dr. Azwa.
Yes.
Thank you. I think we already addressed all questions from the group chat. I will invite participants. If anyone wants to ask question directly to one of our speakers, you can raise your hand or you can directly unmute yourself. Okay, 1, 2, 3. No, we don't have anything. Maybe I will close with one last question for Dr. Kemas, because I think that you didn't have any question from the chat box. Maybe because you have your the last question of this presentation. I want to ask you, Dr. Kemas. You said that semantic analytics is important in big data, and then what I was curious about, is it possible that the semantics is changing over time? And how should we handle that?
Can you repeat again the question?
Is it possible that the semantics is changed over time? So maybe previously we meant something and the semantics is changing now. We use the same words, we use the same predicates, but it means something else. Is it possible?
So you mean temporal, right?
Yes.
Yeah. There are two research in semantic, temporal semantic and also just usual semantic. What I did is usual semantic, but in temporal semantic community, they deal with the one that you asked. So if we want to analyze, for example, the evolution of this topic, was it still valid 20 years ago, and is it still valid today, and will it still be valid in the next 20 years? So they answer it by using temporal knowledge graph. So they deal it with enriching the static knowledge graph with temporal information. So in semantic, if you have more and more problems, you just need to enrich the RDF triples. That's the way they deal with. They just add.
We can see how the graph has changed over time because of the semantic changing.
Yeah. So the graph will be more heterogeneous. Dr. Imelda showed very beautiful graphs, yeah, colorful. So if you want to add temporal, so it will be more variety, yeah. But it's very, very challenging. It's not easy to do reasoning with this temporal dimension. Yeah.
Okay, thank you. And I think that is the end of our question and answer session. Thank you for all speakers for your outstanding presentation and also great discussion during the question and answer session. Also, thank you all participants for your cooperation during the sharing session. And as a final remark, we will have a photo session. So I will ask all participants to turn on your camera, and I will hand over to our host to lead the photo session. Our host, Ms. Serena.
Okay.
Okay.
Okay, I will do screenshot. Okay, thank you everyone.
Okay, thank you. Dan selamat Hari Raya Adha dari kami.
Thank you. Happy Eid Mubarak Idul Adha.
Ya.
Bu Tisa. Halo Bu Tisa.
Halo Pak Dr. Kemas. Nice to hear your speech.
Yeah, thank you. That's all for today. Thank you for your attendance. Stay safe and healthy. See you next time.
Okay.
Bye-bye.
Thank you. Bye.